we just talk about this graph, now I would like to talk about the displacement time graph. So let's discuss the displacement time graph here. So let's take a broader marker to explain it in the right way. So let's do it. Let's go for it. I'm taking this pink marker with the broader left. So that will be broader, right? So this is a simple that we are getting here. So we have to tell them which correspond to it which graph is correct. Like this graph is something like this. This represents the displacement. This represents the time, and the slope is decreasing, which means it has a negative slope. And why we get negative slope, that will be I'm be sharing that trick to remember that whether your slope is negative or positive. So this is negative slope. And if you see one thing here, it's like taking a sharp nib. I'm going to show you one thing, that theta is here is constant at every point. If you're going to draw a tangent here, your theta is constant, which means if your theta is constant, like same at every point, but your velocity is constant at every point. Your velocity is constant. You can account it of constant velocity here, which means it's just a constant velocity. Okay, so let me do it. It's just a constant velocity here. Velocity here is just constant. So if velocity is constant, we can say that acceleration is zero, right? Acceleration is zero. Zero, no change. No change. So you have to answer it, correspond to it, which graph is correct. So let's do it. Let's go for it. So let's take a broader nib for it again. Like this. Let's go. So first of all, the graph that we are getting here is this one graph. I'm gonna make it with a different color so it will be prominent, right? So the first graph that we have is this graph. This is displacement time. I'm not writing again and again displacement time graph. So this is displacement velocity time graph. So let's take the example of second graph, which is something like this. Like this. So let's represent this graph like this. Yeah, so this is something like this. Drawing the tangent here. So this is displacement time graph, right? So that's the second option that we are getting here. So I'll explain you each and every graph and what exactly it's representing. So let's get the example of next graph, which is something like this. Like example of this graph. So this one graph is just going here, something like this. So yeah, so this is velocity time graph. This is velocity time graph we're getting here. So for a while you can consider this is also velocity time graph. This is also velocity time graph. So let's not discuss about the displacement time graph here. Let's talk about velocity time graph. So these are the three. First of all, I'm going to discuss about DC velocity time graph. So we're discussing about the last option. So this slope is constant. As you can see that here the slope is also constant going right, but you can see here the slope is decreasing. Like here the theta is constant, but the slope is decreasing. And you can see this slope is constant, which is parallel to the time axis. So we can say that this cannot be the right answer. If we talk here, then it's pretty obvious that the velocity is here is increasing in this direction, and theta is also not constant. If you're gonna draw a tangent from here, the tangent is something like this. We're gonna tangent from here, this is something like this. If we're going to tangent for here, so something like this. Angle is 90, but it is increasing with the passage of time. If we talk about it, you can see here velocity is increasing in this direction. It is, for example, if you're going to write here -2, so velocity is increasing in direction, although it's in negative direction, it cannot be option as well. So this is also not an option. So let's deal with the last with exactly the option here. So I'm going to draw this here with the help of this marker. So let's draw it. Let's take a bronze nib for it. So let's draw. I'm going to draw it here. Something like this. The exact right answer is this, which is this. Wait for a while. Basically this is the right answer. -2 velocity time graph. As you can see here, first of all, the velocity here is constant, and second thing is that it's -2, which means the slope is negative here. It's constant, negative, no acceleration. So this is the right answer of this question, right? So this is the right answer that I can say, right? So let's just erase it and let's deal with the other question as well. So let's deal with the other question, which is okay. You have to identify it, right? This is what does exactly represents and what does it mean. So I'm drawing a graph here. This is something like this. This is something like this. It's a graph here, and this drawing something like this. So what is exactly? Let's do it. Let's take example. Let's take a help of this color. If I'm going to draw a spot here and drawing a tangent from this point with tangent something like this, you can see here it's not prominent, but if you're gonna take the very sharp nib, it will be prominent. Angle is prominent here. It's just 90 again, right? 90. We always take angles in the right direction. Then we're gonna draw a tangent from this point. It's not clear just because my marker was just not too sharp. So you can see here the angle theta is less than 90 here. If theta is less than 90, what does it mean? It means that your velocity is positive. If your velocity is positive here, what does it mean? You can see here the theta is not constant here, it is increasing with the passage of time. So you can say that if velocity is positive, velocity is increasing. And if velocity is increasing, it's pretty very obvious your acceleration is increasing as well. So from this we can interpretation that we can make here is that yeah, if theta increases, theta increase, velocity increase, velocity increase, acceleration increase, acceleration increase, both are in the same direction that we can interpret it through this thing. And one trick that you need to remember that I'm giving here is that if you draw tangent something like this, it represents the negative tangent. It represents negative tangent. And if you draw a tangent something like this, it represents positive tangent. It represents positive tangent. So this is negative tangent, this is positive tangent. So remember while dealing with the quotient, so now you can easily interpret it either velocity is increasing, acceleration is floating, theta is less than 90, and then we can say velocity is positive. And yet one again trick that you need to remember while dealing with this sort of questions. Let me just erase it and deal with it. So let's draw it. I don't have a perfect marker for it, so I will try to draw it in the right way. So if it just okay, so oh my god, I need to draw U sort of shape, and I don't think so it works. Okay, let's just erase it. Okay, I'm just trying to have a more marker which is rounded shape. No, I don't know. I'm not getting it. Okay, yes, I've got it. Let's take this color. It's lilac. Okay, this is basically U. I'm just trying to make it in a perfect. Oops. Yeah, nice attempt. Okay, one more is something like this. So, if your U is concave, if you have a concave upside in the upward direction, if you have a concave in the upward direction, concave, oops, I need a marker, let's take it, concave, if you have concave in the upward direction, which means the acceleration is positive, concave in a upward direction, concave in a upward direction, which means that your acceleration is positive. And if your concave is in downward, this is positive concave. And for a while consider that your concave is in downward direction. If your concave is in downward direction, which means your acceleration is negative, right? Your acceleration is negative, right? So this is the